When we lift our eyes to the night sky, we see an infinite number of stars. Each point of light, a distant sun, could be home to unknown planets. This sight engages us in a question as simple as it is profound. Are we alone in this vast universe? Imagine for a moment, could there be someone somewhere, under the light of a distant star, staring into space, wondering if there are other thinking beings scattered throughout the cosmic immensity? Is there, in some remote corner of the galaxy, a civilization that, like us, reflects on its existence and has also achieved technological advances? In this search for answers, one name stands out: Frank Drake, an astronomer who has given us a fascinating tool to explore this question. The Drake equation, as it has come to be known, offers a way of estimating the number of civilizations with which we could theoretically communicate. This equation opens the door to imagining possible scenarios in a universe populated by other thinking minds, or conversely, in a silent cosmos. The real magic of the Drake equation lies in the way it distills the complexity of the universe into an apparently simple formula. We start with the formation of stars, those beacons of light and heat that punctuate the darkness of space. Each star is a furnace of possibilities, capable of starting a planetary system. But not just any star will do. We need those that have the right conditions to host planets in their orbits. From there, the equation guides us through the probability that these planets are more than just celestial bodies spinning in a void. What are the chances of a planet having the perfect combination of elements to support life? It's not enough just to exist. It needs to be in the habitable zone, have water, an atmosphere, minerals, and a multitude of other conditions that turn a world of possibilities into a home for living beings. Moving further along this chain of cosmic events, the Drake equation leads us to contemplate the origin of life. This singular moment when inanimate matter becomes alive is perhaps the most mysterious of all. How and why does life arise? And once life has arisen, what is the likelihood that it will evolve into ever more complex forms, eventually reaching intelligence? The Drake equation is expressed like this, where R represents the rate of star formation in our galaxy. Fp is the fraction of these stars that have planetary systems. Na is the average number of planets per planetary system that could support life. Fl is the fraction of these planets that actually develop life. Phi is the fraction of these planets with life that develop intelligent life. Fc is the fraction of these civilizations that develop detectable communication technologies. L is the average duration of these communicative civilizations. As we dive into each term of the Drake equation, we're not just doing calculations. We're pondering the deepest mysteries of existence. We are searching for our place in the cosmos, trying to understand how, out of infinite possibilities, we are here, pondering stars, planets, and the incredible chain of events that brought us to this point. The beauty of this equation lies not only in its ability to estimate life beyond Earth, but in how it connects us to the universe, reminding us that we are part of something much bigger. As we dive deeper into the cosmic ocean of knowledge, recent discoveries offer us a transformative view of the universe. The evidence accumulated by astronomers through advanced telescopes and space missions reveals that the presence of planets around stars is more the rule than the exception. This understanding broadens our horizon significantly, opening the door to a universe full of potential homes far from our solar system. The idea that almost every star that twinkles in the night sky could be the sun of one or more worlds is not only fascinating, but also an invitation to imagine the countless possibilities of environments that these planets could offer. However, with this expansion of our understanding of the cosmos comes even deeper questions about the nature of life. The existence of countless planets suggests a vast array of scenarios where life could theoretically flourish. But the emergence of life, this complex and delicate phenomenon, remains one of the great mysteries of science. How does something as extraordinary as life emerge from inorganic matter? What chemical and physical processes converge to transform atoms and molecules into living structures capable of replication, metabolism, and eventually consciousness? Even more fascinating is the question of the evolution of this life, from simple to complex, from unicellular to multicellular, culminating in life forms with the ability to question their own existence. What is the probability that somewhere among the billions of galaxies in the universe, not only life has arisen, but beings capable of learning, adapting, and perhaps even gazing at the starry sky, wondering if they are alone in this cosmic vastness. This question is not just academic, it touches on something fundamental about our very nature. The search for extraterrestrial life is, in many ways, a quest to better understand ourselves, our origin, our place in the universe, and our destiny. Each new exoplanet discovered, each advance in our understanding of how life can arise and develop in environments other than our own, brings us one step closer to answering these fundamental questions. So when we look at the sky with curiosity, every star potentially hosts a world, a chance for life. The universe, with billions of stars accompanied by planets, presents itself not only as a vast space to be explored, but as an invitation to dream of the possibilities of finding other forms of life that, like us, seek to understand the great enigma of existence. At this point, the plot of our cosmic exploration becomes dense and enigmatic. When we look at Mars and Venus, our closest celestial companions in the solar dance, we see a stark reminder of the complexity of life. These planets, with their own geological and atmospheric histories, serve as natural laboratories, teaching us that the existence of liquid water and a wealth of minerals are not enough to guarantee the emergence or maintenance of life as we know it. Mars, with its dry valleys and ancient riverbeds, suggests that it once had plenty of water, but today it is an icy desert where life, if it existed, has left few or no perceptible signs. Venus, meanwhile, with its thick, toxic atmosphere, presents a greenhouse scenario taken to the extreme, a reminder of how delicate and precise the right conditions are. Earth, our home, is the only place in the vast cosmos where we are absolutely certain of the presence of life. Here, on our own planet, life has not only arisen, but flourished in dizzying diversity, from the depths of the oceans to the heights of the heavens. However, even in the face of such a miracle, the exact origin of this vital spark remains shrouded in mystery. Scientists from various disciplines are joining forces to unravel this enigma, studying fossils, rocks, and even the chemical composition of the ancient atmosphere, looking for clues as to how the complexity of life emerged from simple organic molecules. This mystery becomes even deeper when we consider the uniqueness of the Earth. Why, among so many potentially habitable planets orbiting stars across the galaxy, is life such a rare phenomenon? Is there a secret ingredient, a cosmic conjunction of factors that has been particularly favorable here, but is absent on other worlds? Or is life, in fact, more common than we imagine, waiting to be discovered in unexpected niches, under icy surfaces or oppressive atmospheres? These questions lead us to reflect on the fragility and value of life. By recognizing that the presence of water and minerals is no guarantee of life, we begin to appreciate the complexity of the chains of events that led to our own emergence. The Earth, with its unique conditions and rich evolutionary history, stands out as an oasis of life in the vast cosmic desert. At the same time, the quest to understand the process by which life arises drives us to look beyond our solar system, dreaming of discovering other worlds where this mysterious spark has also been ignited. Within this enigma, the Drake equation allows us to play with numbers, varying between optimism and pessimism, to estimate everything from a universe full of communicating civilizations to the solitary existence of humanity. But even beyond the calculations, this equation makes us ponder the future. If other civilizations existed, what determined their fate, and what does that mean for us? Carl Sagan, an invaluable voice in space exploration and reflection on our own civilization, reminds us that the greatest threats can come from ourselves. The ability to overcome our technological and environmental challenges is perhaps the last and most crucial term in the equation of our existence. So, as we look to the stars, wondering about life beyond Earth, we also face questions about our own survival and legacy. We are on the verge of discovering whether we will be one of many cosmic voices or a brief whisper in the history of the universe. Thank you very much for accompanying me on this journey, and until next time, when we will once again explore the mysteries of the cosmos together.